So, Year 10, electromagnetic waves. Today we're just going to be looking at light, infrared and micro radio waves. And for today, our learning outcome is to describe the nature of white light and describe the uses of infrared, radiation, microwaves and radio waves. Explain the meaning of mobile phone radiation. Explain why these types of radiation may be hazardous. So, first of all, a bit of a crossword puzzle, something slightly different today. And here are your clues. So pause the slide and have a go at completing this. Here are our answers. So light. Now, light from ordinary lamps in the sun is called white light. It might be different variations of white light, cool white light or warm white light, but essentially it's still white light. This is because it has all the colours in the visible spectrum, and when these are all blended together, then it appears white. We can separate those using a prism, as in the diagram below. And that prism will then separate the light out into the spectrum that we then know that makes up visible light. This is why we see rainbows, because actually when we get rainbows just after it's rained, and the different density of the air with the water moisture in it as light is passing through it separates out those different waves so that we can see the different colours of the rainbow. So, the visible light spectrum. Again, this is slightly the wrong way around, but there you are. So these colours were blended together to produce white light. Infrared radiation. So all objects give off infrared radiation, and that is essentially heat thermal radiation. And the higher the temperature of an object, the more infrared radiation it will emit, so give out. So if we look at our infrared image of the dog next to us, the bits that are the warmest are red, and the bits that are the coolest are purple. Not only do the objects give off infrared radiation, but they also absorb it. So we do need to make sure that we're applying those rules of energy transfer that we did, the conduction, convection, radiation, and that does come into this unit from Unit 1. So when an object at a constant temperature is absorbing and emitting infrared radiation, at the same rate, therefore the objects that are good at absorbing are also good at emitting. Perfect black body will absorb all of the radiation that hits it, and that means that it's very good at radiation too. Now, some people may ask why our radiators in our homes are not black, And it's simple, actually. If we have black radiators, the minute we switch them on, A, they might not be very attractive, but secondly, they would then, as soon as the hot water went through the first radiator, it would then emit all of the heat, and there would be no heat travelling to the second, third, fourth radiators in the system. So black body radiation is the radiation emitted by a perfect black body. So let's look at infrared radiation. Now, infrared radiation is really important. As we've talked about, all bodies emit infrared radiation. And so therefore, some of them are hotter than others. And if they're hotter, they're emitting more radiation than those that are cooler. And thinking about the wavelength of infrared radiation, it's 790 nanometers to 0.1 of a centimetre. So about the size of an ant. And the interaction is reflected by the smooth, shiny surfaces and absorbed by dark, matte surfaces, and they transfer heat. Okay, cool picture of a rhino. And uses, we use these for remote controls, heating, thermal imaging, motion sensors. It's really important that you then just pause the slide now and just make sure that you've got those pieces of information down. You can do it as a mind map, really. It'd be good to build up yourself a set of notes based on these. So if we go to microwaves, now the sources of microwaves, it's an alternating current through an antennae generating magnetrons, and they have a wavelength of around 0.1 centimetres to 30 centimetres. Doesn't sound that micro, does it really? However, they have several uses. We use them for radar, heating foods, mobile phones, and other types of communication. There's a little bit of safety here. Sometimes they talk about safety in microwaves. Now, there is lots of links to the uses of microwaves in our phones and potential increased risk of cancer. Although a huge amount of research has been done, nobody's been able to prove this. However, I think it's not advised that you keep your phone in your pocket if you're a young man because of your testicles, and the fact that the microwaves could be whilst your phone's sort of updating itself via data networks. Those microwaves could be slowly cooking the tissue around the area of your pocket. The same as if you're a young lady that wants to keep a phone in their bra. Again, it's not a good place to keep it. It doesn't look very attractive, and it is highly suggested that this could be linked to breast cancer. Okay, and that is purely for the heating effect of the microwaves around the tissue and the lymph glands that are found under your arm and in your breast and in your groin. Okay, so the interaction of these, they're reflected by metal, they're absorbed by living tissue and some other soft materials. So that links back to the safety aspects of microwaves again. So radio waves. Now this is slightly different. We've got an alternating current again through an antennae, and they vary in length. So they can be a few centimetres long to kilometres long. And that means that they have a much more versatile set of uses. And we use them for TV broadcasts, satellites, radio, and other types of communication. And they pass through most materials. However, they are very easily reflected, and that's why if you've got digital radio, it is quite often you either get a signal, don't get signals in valleys, etc., because they don't able to reflect down into valleys, they cross the top of them. We'll do a little bit more about this later. So there is a required practical that goes with this that you will have done before. However, I'm just going to talk over it so you know what to do. There is a link to the required practical at the bottom, and here it is. So you have two tins, one is silver, one is black. You put the same temperature water in both, you put a thermometer in both, and then you see which one cools down the fastest. In reality, this never really works particularly well for a whole variety of reasons. However, what we can see if we do this on a much larger scale, which I've done before with metal dustbins in a larger volume of water, is fill those metal dustbins right up. So we've got a nice large volume of water, paint one black and get one super shiny, and measure the temperature over time using a digital probe. It's much better doing it with digital probe because, to be honest, who wants to watch water cool? It's not exciting. And what you will see is that the black can loses heat much faster than the silver can, because black bodies are much better at emitting thermal radiation. Okay, it's good to do this outside, but again, it doesn't work particularly well if you do it on a sunny day, because black bodies are also really good at absorbing thermal energy or infrared radiation. Okay, so you can watch this practical being done by another very exciting physicist at the link below. I've added it to the show my homework at the bottom. Feel free to watch a really riveting practical. Alternatively, just use a bit of common sense, but it's worth making a note. This is one of the practicals they would really like you to be able to do and explain. So we've got a little bit of a quiz. It's not going to take very long. So, number one, what part of the electromagnetic spectrum has the largest wavelength? and that's our radio waves. What is the danger associated with gamma rays? They cause cancer. They cause cellular mutations. They damage DNA. What are microwaves used for? Now, you could have any sort of answer for this, one of the following: heating food, microwaves, communications. Okay. What is the highest frequency on the electromagnetic spectrum? And that's gamma rays. What are the uses of UV radiation? Now, this is the bit of the radiation we haven't really talked about at the moment, but that's the bit that gives us the tan. Okay. And we can use UV radiation to detect counterfeit banknotes and in sunbeds. What are the uses of gamma rays? Sterilising hospital equipment and killing cancer cells. And what types of electromagnetic radiation have the higher wavelength than infrared? Radio waves and microwaves. Now, should the number of hours, this is one of a hypothetical question that they want you to think about, is the fact that the number of children that are increasingly getting cancer could be linked to the use of mobile phones at a young age. Now, big question that they asked last year was, should the number of hours that children under the age of 16 spend on their mobile phones be limited? And this was a 6-marker, a discuss question. Think about this, see what you think, write down the advantages and disadvantages. I'd be interested to see what you've put. Please feel free to email that to me.